declare a variable, but you didn't give them a value. Like, hey, this is static int, static variable, but you just this. It didn't have an equal operation and a value of that. This value will log into our uninitialized data segment. Okay? So this is a sample of static memory. It's how global memory work when you do your functions. And the bottom of the memory layout is a text or code segment. It's the part that contain the program executable code, including main function, printf functions. It's also include machine instruction. It's the part that computer, it's the part that is tell the computer that, okay, where you gonna start? You're gonna start from ahead and downstairs to the bottom, and you're gonna look for the main first, something like this. It's called text segment, and it is our static memory. Okay, now you know static memory. You know that if you declare a global variable, it will log into a data segment. And if a computer have a standard to instruction that computer do this first, do that first, it will log into text or code segment. And next, you will know about dynamic memory. Dynamic memory, it's refer to organizations of memory that you actually allocate the data during the executions of a program. Unlike the static memory layout, where memory allocation is determined at compile time. Dynamic memory layout involves allocating memory at runtime as needed by the program. In conclusion, I will tell that heap is referred to a regions of memory used for dynamic memory allocations, where memory can be allocated and deallocated at runtime. Which means your one memory, and you say to computer again that, okay, I use it and I don't want it. And number two, it's a stack. Stack is referred to a region of memory used for managing functions, call information, and local variable with automatically memory management, which means every time you use your function, almost every function will need to use a stack. But heap is used when you need to allocate that memory in your function. Okay? And the difference between malloc and stack. You will need to do malloc functions on your libfft, and you will don't know why you need to use malloc, why you don't just use a stack. A typically different on two of this is if it's a malloc, it means, okay, first, let's get a stack first. If it's a stack, it means you declare functions. Every time you declare, it's put in your stack, and every time functions end, it's some kind of return a value. If you see in that pictures, it's return a value. When it's return a value, it means stack it pop out. That function pop out of the stack. So, which means you cannot access any local variable on your function in that stack. But if we go into malloc, malloc it's about you desire, you want to locate some memory, which is if you call a malloc, you will going to involve with something called heap. Heap is a place that your malloc can call them a function. The malloc function will ask you how much memory you want to allocate in byte unit. Like, if you want a size of integer, you just put an int into a function of malloc, and it will malloc for 4 bytes. And if you want a much more than that, you just change it to something else, like characters, like whatever. And so one block of memory will allocate on the heap. Next, malloc will return a void pointer in the starting address of the memory. We figure out that address is 2000 in this example. P and A is local variable of the main. So you will see that it has a main, it has a variable called P and A. It's on a stack. And it has PA. So you call malloc functions on a P. So P is pointed to the address of 2000. And if address of P is pointed to 2000, it means you can assign any value in that. Let's say you assign 10. So it's be 10. And if you want to free, you just passing pointing address of the memory into that address again. Like this is 2000, right? If you want to free, you just move your pointer into 2000, and then you free, and then you put a P on a free function. So now the first block of the memory will be clear. It's something like that. This is a concept of the heap and stack. Also malloc and stack too. Okay. Today it's end again. I hope that you will get something more, or if you have a questions on a stack, on a mallocs, or how that frees, or something like this. Like when you stack, it has all your functions on that. It have, firstly, the functions need to find a main first. So the main's going to first thing that it's searching for. So, and another one would be push in, and then it will pops out when it's returned some value, and then that function will not use anymore. And you cannot access, like, you cannot access. But if you use malloc, if you not free your malloc, you can actually access them. Yeah, this is a main difference of a malloc and stack. Okay. Now you know about memory layout. We have dynamic, we have static. And you know the difference about malloc and stack. Malloc is, you can access them. Eventually you free it. And stack is, if that function return a value, then that like stop, you cannot access it. Address is disappear and you don't know where it is. Some kind of this. Okay, this is stack, malloc, and free. Okay, I think that today you will get like something out of this. Okay, you get it? Thank you.